Okay, good afternoon. We're going to get started. Welcome. I'm very excited to speak with you this afternoon about AWS's newest storage offering, the Amazon Elastic File System, or EFS. My name is Edward Name, and I lead product management for EFS. During his keynote this morning, Andy Jassy briefly introduced EFS to the world. And during this session, I'm going to provide details on EFS's features, its benefits, and how it can be used. Before I get started, though, let me talk about goals and set expectations for the session. My overall goal is to introduce you to EFS. What is it? What features does it have? And how can it help you? The session is intended for folks of all levels, so we'll cover both beginner topics and more advanced topics. And as a heads up, I won't be doing a live Q&A at the end, so if you have questions you'd like to ask at the end, please go to the new AWS Services booth, and folks from the EFS team will be there to chat with you one-on-one. So what will I cover? Well, first, I'll provide an overview of EFS. I'll talk about how it fits into our current portfolio of storage services. I'll talk about some of its key features, and I'll talk about why those features matter. Secondly, I'll dive in. I'll talk about EFS from a more technical perspective, and I'll focus on what it means to create a file system and how you access a file system from an EC2 instance. Then I'll do a live demo of creating a file system. So you'll see with your own eyes what that looks like, and I'll also show you what it looks like to mount a file system to an EC2 instance. Fourth, because security is critical to all of our customers, I'll spend some time talking about security mechanisms that you get with EFS. And then finally, I'll talk about how EFS spreads data across data centers and what that means from a data availability and data durability perspective. OK, so let's get started. And let me begin by talking about our current storage portfolio and how EFS enhances our current set of offerings. So before today, we had three storage services: Amazon Simple Storage Service, or S3, Amazon Elastic Block Store, or EBS, and Amazon Glacier. S3 is object storage. And an object is a piece of data, like a document, or an image, or a video, that's stored with metadata, and it's stored in a flat, non-hierarchical structure. And we call that structure a bucket. You access your objects in S3 via an API over the internet. It's a very simple API. And S3 allows you, for example, to create a highly scalable web application that, for example, serves rich media content to end users, and you do all of that by interacting with the S3 API over the internet. EBS is block storage. And with EBS, your data is presented as disk volumes to your EC2 instances. And EBS provides our very low single-digit latency access to single EC2 instances. And Glacier is archival storage. It's our cheapest storage offering, and it's intended for data that's accessed very infrequently. And now today we have EFS. EFS is file storage. And with EFS, data is presented to your EC2 instances via a file system. EFS provides shared low latency access from multiple EC2 instances concurrently. So what are the features of EFS? It's a fully managed file system for EC2 instances. So there's no hardware to maintain and no software file layer to maintain. It provides standard file system semantics. So you get what you'd expect from a file system. You have read after write consistency. You have the ability to store your files in a hierarchical directory structure. And you have file operations like append and atomic rename. And you have the ability, for example, to write to a block in the middle of a file. It works with standard operating system APIs. So EFS appears like and acts like any other file system that you would have attached to your EC2 instance. So applications that leverage standard file system or standard operating system APIs to work with files will work with EFS. It's shareable across thousands of instances, so it can serve as a data source for applications that span multiple EC2 instances. EFS elastically grows. Every file system elastically grows to petabyte scale. And you don't specify a provision size up front. You just create a file system, and as you add files to it, the file system automatically grows. And as you remove files from it, the file system automatically shrinks. And you pay only for the storage space that you're consuming. EFS delivers performance for a wide variety of workloads. EFS is SSD-based, provides consistent low latency operations, file operations, and it provides high levels of throughput and high levels of IOPS. It's highly available and durable. EFS spreads data across AZs within a region. And that means that from an availability perspective, your data is highly available. It also means that you can have instances running in multiple AZs, and those instances can access the same file system. And it also provides another layer of durability or protection against data loss. And EFS is NFS v4 based. And for those of you who aren't familiar with NFS, NFS is a network protocol for interacting with file systems. So when your instance is talking with your EFS file system, really it's sending traffic over the network via NFS. And NFS is an open standard. It's widely adopted, and it's included on virtually all Linux distributions. EFS is designed for a broad range of use cases. And let me walk you through a few examples. Content management systems or content repositories store and serve information for a wide variety of applications. For example, online publications or reference libraries. You can use EFS as a highly durable, high throughput storage layer for these applications. Development and build environments often have hundreds of nodes accessing a common set of source files, of binaries, and of other resources. You can use EFS as the storage layer for these development and build environments, and its high level of IOPS will well serve demanding dev and build needs. Many organizations provide shared file storage for groups, and they also provide file storage for individuals. For example, research scientists often share large data sets amongst each other, and each of them typically performs ad hoc analyses on that data. But each research scientist typically also has their own home directory with their own files in it. With EFS, an administrator can create a file system, and they can specify that part of that file system is accessible to a particular group or a particular organization. And so there's shared data within that part. And part of the file system, or different parts of the file system, are accessible only to specific individuals. And big data workloads often require file system operations and read after write consistency, as well as the ability to scale to high amounts of storage and high levels of throughput. EFS can provide file storage that EC2 clusters can work with directly for big data workloads. So why did we build EFS? Well, because operating shared file storage today is a pain. If you're an IT administrator providing file storage for your company, You need to estimate storage demand for the many groups and organizations you're supporting. You need to procure hardware. So you need to evaluate different hardware orders or different hardware options. You need to cost out those options. You may need to build 1 or 2 cost models. You need to work with your procurement team. You need to track orders. You need to set aside physical space for the racks the storage will be part of. And you need to set up and maintain hardware, of course. And if your network can't deliver the throughput that you want to provide to your storage, you need to upgrade your network. And you need to perform constant monitoring of access. You need to monitor for security breaches, etc. If you're an application owner or developer, you need to estimate your need for storage and spend time building a business case for why you need this space and why the business should invest a large capital amount of money up front. You realize that procurement times can be long, and storage isn't necessarily available when you are. And you need to worry about how quickly you're going to eat up your storage space because you don't want to run out, and you know that there are these long procurement times. And you can't be as agile as you might want. You can't run quick experiments. You can't spin up storage and spin it down quickly. And as a business owner, you need to make an upfront capital investment for your equipment. You probably are overbuying because of the long lead times, and you don't want to run out of space. And even in steady state, you're not going to want to completely fill your disks, because usually bad things happen when that happens. And most importantly, or I should say worst of all, you're diverting your attention away from your business mission. With EFS, we set out to change the current state. And if there are 3 things that I'd like you to remember about EFS coming from this session, here are the 3 things, and they're interrelated. The first is that EFS is simple. The second is that EFS is elastic. And the third is that EFS is scalable. And let me talk about each of these in turn. EFS is simple. It's a fully managed service, which makes it simple to administer file systems at scale. You have no file layer, no software file layer to maintain. You have no hardware to manage. You don't have this ongoing maintenance that you need to worry about and these never-ending upgrade refresh cycles. There's no volumes to worry about, no RAID groups, no LUNs, no provisioning to deal with. And you can create a scalable file system in seconds. And that's probably hard for some folks in this room to believe who've managed file storage in the past. But I'll show you a little later how quick it is to actually create a file system and start using it. It provides seamless integration with existing tools and apps. Again, it's NFS v4 based, which is widespread and an open protocol. It supports standard file system semantics, and it works with standard operating system APIs for interacting with files. And it has simple pricing. You simply pay for the amount of gigabytes that you store per month. And that's it. So the simple pricing makes it easy to forecast your costs. EFS is elastic. File systems grow and shrink automatically as you add and remove files. There's no need to provision storage capacity or performance. And I shouldn't say there's no need. There's actually no way to do that. It's completely elastic. And you pay only for the storage space you use. And EFS is scalable. File systems can grow to petabyte scale. And as they're growing, there's no need to reprovision, adjust performance settings, or do anything in order for your file systems to grow. EFS just does it all automatically for you. It provides throughput in its IOPS scale automatically as file system grows. With each gigabyte stored, you get a particular number of IOPS and a particular amount of throughput. So as the amount of storage space you're using grows, the throughput and the IOPS you can drive to that storage increase automatically. provides consistent low latencies. Lots of workloads are latency sensitive. EFS is SSD-based, and low latency file operations are a core part of our design. And EFS provides support for thousands of concurrent NFS connections to the same file system, which allows you to use it as a common data source in large clusters, or more broadly for really any use case where you have multiple nodes accessing a single data source. So coming back full circle now, why does all of this matter? To IT administrators, EFS eliminates the need to manage and maintain file system storage at scale. To application owners and developers, EFS makes it easy to move existing code, applications, and tools that are used today with existing NFS servers to the AWS cloud. And it also provides a very simple shared file storage solution for new cloud-native applications. And to your business, EFS offers predictable pricing with no upfront investment. It allows you to have increased agility. And it allows you to spend less time managing file storage and more time focusing on your business. OK, so now that you've had the overview of EFS, let's dive in. And let's talk about EFS more from a technical perspective. And for the sake of those in the room who might be new to AWS, before I start talking about EFS specifics, let me define a few AWS basic building blocks: a region, an availability zone, and a virtual private cloud, or VPC. A region is a geographic area where AWS services are available. And each region is designed to be completely isolated from other regions. And that achieves the greatest possible fault tolerance and stability. Customers choose regions for their AWS resources. So for example, when you launch an EC2 instance, you specify the region that the instance should be in. And customers, for example, will choose a region based on latency requirements or based on legal requirements. And currently, there are 11 regions worldwide, and that number is growing. So what's an availability zone, or an AZ? So each region has multiple isolated locations known as availability zones. And really, an availability zone is a logical group of data centers. There are low latency links between AZs in a region, so that makes it really easy to have applications that span across multiple AZs within a region. And again, when you're launching a resource or you're launching an EC2 instance, as an example, a customer will choose an AZ. So the customer chooses a region and then an AZ within that region. And note that some customers distribute their instances across multiple AZs in order to have extremely high fault tolerance. And today we have 28 AZs worldwide. And then virtual private cloud, or VPC. A VPC is a logically isolated section of the AWS cloud. It's really a virtual network defined by the customer. When launching instances and other resources, you place those resources within a VPC. And all new customers have a default VPC, but you can create your own VPC as well. You can create many, many VPCs if you'd like. And a lot of customers do that. OK, so now coming back to EFS. What is a file system? Well, file system is the primary resource in EFS. It's where you store files and directories. And you can create an unlimited number of file systems per account. To access a file system from an EC2 instance, you mount it. And mount is a standard command. And after you mount it, the file system will act like a local set of directories and files to your instance. And note that an NFS v4 client, which is required in order for you to be able to mount an NFS file system, is standard on Linux distributions and is available for Windows as well. So the mount command that you see on the screen here is a pretty basic command. The -T is for the file system type. In this case, it's an NFS4 file system. You provide the file system's DNS name, and I'll show you in a second how that's created and how you access that. So every file system has actually several DNS names, and I'll explain that in a second. And then you specify the local directory that the file system will be attached to. And that's it. So on the previous slide, you saw that there was a DNS name in the mount target. And that's something that's created when you set up your file system. And it's provided by something we call a mount target. So to access your file system from instances in a VPC, you create mount targets in the VPC. And a mount target is an NFS v4 endpoint. So just think of it conceptually as that. And a mount target has both an IP address and a DNS name. And you can use either of those in your mount command. So that's what provides the DNS name that I was referring to. So how does it all fit together? So to recap, you have a region, you have a VPC, and this is owned by the customer, the VPC, and VPCs span multiple AZs within a region. You, the customer, will have EC2 instances in your VPC, and those will reside within particular AZs. And in this example, we have EC2 instances in 2 of the 3 AZs in this region. And then you have mount targets within each AZ, and those act as the endpoint to the file system. And that's what the EC2 instances send their traffic to. We provide an API that allows you to administer your EFS file systems. And all of the API's functionality is available to you in 3 ways. The first is via the AWS Management Console. And that's AWS's browser-based management tool. The second is via the AWS Command Line Interface, or CLI. And the CLI is a tool that you download to an instance or you download to a local machine. And it provides scripts that allow you to manage your AWS resources from the Windows or the Linux or the Unix or Mac OS shell. And then the AWS Software Development Kit, or SDK, which provides support for Java, Python, PHP, .NET, and a few other languages for EFS. In the console, the CLI, and the SDK each allow you to perform a variety of management tasks. So I mentioned the API was really there to allow you to administer your file system. So what does that mean? What are the types of things you can do? You can create a file system. You can create and manage these mount targets that I was talking about. You can tag a file system. So you add tags to it to describe what the file system is for and any other details you want to provide about it. You can delete a file system. And you can view details on the file systems in your AWS account. So you notice this isn't actually a very long list. And that's because there's not much administration that's required of EFS file systems. As I mentioned earlier, we designed EFS so that setting up and beginning to use a file system takes under a minute. And let me pause for a moment, because for those in the room who have managed either on-prem file systems or file storage, or in cloud file systems or file storage via some sort of layer on top of cloud infrastructure, that statement is likely staggering. And keep in mind that after you create the file system, there's no maintenance to do. There's none. So what are the steps to set up and get access to a file system? Well, first, you create a file system. And creating a file system is a simple API call. And again, you can use the console, you can use the CLI, or you can use the SDK to create the file system, to make that API call. The second thing you do is you create a mount target in each AZ from which you want to access the file system. So you pick the VPC that you want instances in that will be accessing the file system, and you create mount targets in each AZ. And again, that's a basic API call, and you can do that through the management console, you can do that through the CLI or the SDK. You then enable the NFS client on your instances. It's a very basic thing to do. And as I mentioned before, NFS v4 clients are standard on virtually all Linux distributions. And then you run the mount command, the command that I showed you a few moments ago. And that's it. You can begin writing files and reading files. So better than my telling you the steps, let me actually show you. So if you can just change to the black screen for a second. Okay. Oh, one more second. Okay. So this is the EFS splash screen within the management console. So if you're new to EFS and you haven't created a file system before, this is the screen you'll see. So to create a file system, I click Create File System. And that walks me through a basic three-step process for creating a file system. In the first step, you configure file system access. And so that's the VPC from which you want to be able to access your file system. And then mount targets within each availability zone from which you want to access the file system. And these mount targets will be created in your VPC. And what is being displayed right now are the default values that will be shown to you if you did what I just did, which was create a file system. We select your default VPC, default subnet to place the mount targets in within each AZ, and default security group. And EFS will work with those default settings. So nothing to change on this screen if you just want to get up and running with a file system. So that's step one. Step two is actually an optional step. And this allows you to add tags to your file system. And this is just metadata that you can add that will help you, when you're looking at your list of file systems, figure out what this file system is for. So we recommend that folks provide at least a name tag for their file system. It's not required, but we recommend it. So I'll call this my first EFS file system. Okay? So that's step two. And then the final step is just reviewing and creating the information from the previous two steps. So the VPC, it's going to go in, and where the mount targets will be set up, and then any tags that I've created. At this point, I click Create File System. And that's it. The file system is created. You now have a file system that can scale to petabyte scale. And let me show you just some of the information that you can see within the console. So it's the information about where these mount targets are. There's basic information like how much storage space the file system is using. So all of the basic information about your file system is available within the console. The other thing that you can get from the console is the DNS names for your file system. So again, these are associated with the mount targets you've created. And these DNS names are what you use when you're mounting a file system to an EC2 instance. And there's a separate DNS name for each of the mount targets, all of the same structure.
What exactly is the mount point at the accrual request?
So yeah, so let's, I'll answer that one quickly, but let's hold questions until afterwards. So the command that we show at the bottom is actually an easy way to not have to worry about what the DNS name is for each AZ. If you actually just enter that, it will actually resolve to the correct DNS name within whatever AZ you're mounting from. Okay, so that's just a sort of snippet that we provide to make it easy. Okay? So now, let me launch an instance. And I created this file system, by the way, in our US West, Oregon region. So the first thing I'll do is I'll create a directory that I'll mount the file system to. So I'll call it mounter. And then I'll mount the file system. So I'll do so here's the mount command, NFS4. Let me copy the DNS name. And let me provide that local directory. Okay, so it's mounted. So you can actually see, here's this mount directory. And you'll note that the owner of the directory is root. So since this is a new file system, the owner of the top level directory is root. So let me actually change that to my EC2 login name, which is EC2 user. So okay. And as you can see, now the owner is EC2 user. So let me go into that directory. And let me open a text editor and create my first file. It'll be a text file. Of course, hello world. So hello world. I love Amazon EFS. Okay, I've saved the file, and I'll exit. And let me just show you now. So you can see there's the file. And let me display the text in the file. Okay, so we've created our first file. And now let me open a second instance. And this instance will be in a different AZ within the same region. So again, let me make a directory that I'll mount to. And then let me mount the file system. Let me just grab the DNS name. Okay, so it's mounted. And let me go into that directory. And as you can see, there's the file that I created from the other instance and the other AZ. And now let me open up my text editor again and open that file in it. And let me add to the file. Okay. So now, let me switch back to my other instance in the other AZ. And let's again see what that file looks like now. And there you go. Oh, it's back. Okay? So that's the demo. So let me just, can you actually switch to the black screen? Thanks. Let me just get back into my presentation. So 1 second. Okay, great. So at this point, we'll touch on a few topics that are a little technically deeper. And the first is security. We know security is critically important to customers, and it's critically important for all of our services at AWS. And as we designed EFS, security was top of mind for us. So let me talk to you about the security mechanisms that are available to EFS file systems. First, at the network layer, you can control network traffic to and from file systems, and it's really to and from these mount targets, by using VPC Security Groups and VPC network ACLs. Second, at the data access level, you can control file and directory access by using standard Linux and Windows directory and file level permissions. So exactly the same way that you would set permissions for a local file system from Windows or Linux. And then third, at the administrative level, you can control access to administrative functions, so control access to the EFS API by using AWS's identity and access management. And I'll talk a bit more about each of these. Before I talk about VPC security mechanisms, keep in mind that only EC2 instances in the VPC you specify can access your EFS file system. So the only way to access a file system is through these mount targets, and these mount targets belong to your VPC. So only traffic through those mount targets in your VPC can access a file system. And security groups, VPC security groups, are these firewall-like rules that you can apply to mount targets, and they specify what traffic can reach the mount targets, and therefore what traffic can reach your file systems. And security groups can have rules like only allow traffic from a particular IP address, only allow traffic from a particular range of IP addresses, or only allow traffic from instances that are within a particular security group. In the example here, we've added to the mount target a security group rule to allow only traffic to and from instances that are part of that security group. So that's an example security group rule that you could add. EFS supports the standard permissions model you're used to when working with file systems on Linux or Windows. It enforces user and group rights at the file and directory level. So for example, you can set permissions for a file so that only the owner of the file can write to the file. So only if the user account that you're logged into on your EC2 instance matches the owner of that file will EFS allow the user on that instance to write to the file. And in this Linux screenshot you see here, you see a set of read, write, execute permissions for owner, group, and everyone, like you would for any file or directory on a local file system. And integration with IAM provides administrative security. So again, you use IAM policies to control who can use the APIs to do things like create file systems, create mount targets, manage the file systems, delete them, etc. And EFS supports action level and resource level permissions. So as an example, you can specify that only particular IAM users can create a file system, or only a particular IAM user can create a specific, or can delete a specific file system. Okay, so finally, let's talk about how we store data in a region. At launch, EFS will be available in 3 regions: in our US West Oregon region, our US East Northern Virginia region, and our EU Ireland region. And in the near future, we'll expand to others. In a region, data is stored in multiple availability zones, AZs, for high availability and durability. So in the event of an AZ issue, for example, if there's a natural disaster that's affecting a particular data center, EFS file systems will continue to be available from other AZs, from unaffected AZs. And you can design your applications to take advantage of this. For example, you can use elastic load balancing, or ELB, to run your applications in multiple AZs. And then if one AZ is experiencing an issue, your application will continue to run and be able to continue accessing your file system from the other AZs. And it's important for me to explain that data can be accessed from any AZ in the region while maintaining full consistency. So your EC2 Instances Connect can connect to your EFS file system from any AZ in a region, and all of the reads and writes will be fully consistent in all AZs. So if you have a read in one AZ, a read of a particular file, you're guaranteed to have the latest data, even if the data is being written, if that file is being actively written in another AZ. So it's full consistency. So wrapping up, I haven't talked much about pricing, so let me do that now. I did mention that with EFS, you pay only for the storage space you use. There are no minimum commitments, no upfront fees. There's no need to provision storage in advance. And as I mentioned, in fact, you can't provision storage. And there are no other fees, charges, or billing dimensions. So you pay for the number of gigabytes you're storing per month times a monthly charge per gigabyte. And that monthly charge per gigabyte is 30 cents. OK, so what do I recommend you do next? You should visit our website at aws.amazon.com/EFS to get more details on the service. And while you're on our website, I recommend that you request an invite for our preview. We'll be starting a preview this summer, so be sure to submit your name if you're interested. And stop by our booth afterwards. It's going to be the AWS New Services booth, and we'll have folks from the EFS team there to answer your questions one-on-one. OK, so that's it. Thanks again. Again, I encourage you all to sign up for the preview so that you can see for yourselves what it's like to work with EFS and see that EFS is simple, elastic, and scalable. Thank you all.